Hi guys, welcome to stats class for today. I'm going to give you a video of the notes, and then your homework tonight is going to be watching another video of notes. When you're done watching this video, you can complete the classwork and then please turn it in to the teacher there. So, what did we learn from the one boy family planning exercise? Well, we learned what expected value is, right? We learned that expected value, right, is what after many trials, how many kids do we actually expect, right? We found that in the way last thing. We also learned that if this was the case, it'd still be equal. So the expected value is after many trials. I'll emphasize that with many trials. What is the expected outcome? Right? And we ended up with, after many trials, the still the expected outcome was that it was going to be, we were expected that family to have 2 kids per family. Expected value, the definition of expected values, right, after many trials, what is the expected outcome, what is the expected value, and we can use that in probability cases. Our definition for expected value is the same thing as the mean, or the average. So we could use mu sub x, or as the average. Or sometimes people use E of x, right? This is just the mean, right? Expected value is just the mean. And E of x in this case, right, we figured out was taking each data point and multiplying it by its probability. And we do that until the very last one. So it was the data point times the probability. So we had how many kids? 1 kid times the probability, 2 kids times the probability, 3 kids times the probability, and so forth. That is our expected value, how many kids that we expect to produce, or we're expected to be in each family. So, another example of an expected value case is we have this first example. So say you're playing a game of roulette. You bet $1 and hope to win big. If the player wins, they bet again $8. If they lose that $1. Right? Below is the probability distribution. So, right, if they lose $1. If they win, they gain $8. So those are the values that we're expecting, or the values that are happening. And then below are the probabilities, right? So the probability that you lose is guess 34 out of 38. The probability that you win is 4 out of 38. Those are just given to us. Before we start, we make sure is this a legitimate probability distribution. We see that it is because 34 plus 4 adds up to 38, so this should sum to 1, so we're good. Are both these numbers between 0 and 1? Yes, so we're good. So it's a legitimate probability distribution. To go ahead and to compute the expected value here, we'll do the expected amount of money that you're going to make. So we do negative $1 times the probability that you make $1, or lose $1, the probability that you lose, right? Plus $8 times the probability that you win. So we're doing our value times the probability. This is our value times the probability. We ended up with our expected outcome, or expected gain of, let's see, I haven't done it yet. We do negative 1 times 34 over 38 plus 8 times 4 out of 38. You end up with a negative 0.052. So what does that mean? Well, what it means is that on average, over a long series of time of playing this game, after many trials, you are losing, oops, 2 O's, $0.05, right? Or 5 cents. So after many trials, you are losing that 5 cents after many trials. So this is where it kind of comes into play. Like if you're at a casino and you're playing, and right, each time you either win or you lose. So you're excited, right? You either get $8 or you lose $1. But if you were to play this forever with these probabilities holding true, on average, forever, you will lose 5 cents. And that's how most games work at casinos, right? On average, you have those great times that you win, so you win, then you lose. If you played for an infinite amount of time, or thousands and thousands of time, on average, you will have lost 5 cents. Great. The second example here is our NHL goals, right? The table below shows the probability distribution of the number of goals scored by a random selected team in a randomly selected game. Well, the first thing we'll want to do is we want to add those all up, make sure they sum to 1. Each of those probabilities need to be between 0 and 1 in order to be a discrete probability distribution. Next, we're going to go ahead and compute the mean, right? The mean or the expected value, right? Those are the same thing. They're called mean or expected value. So we're going to go ahead and calculate that. So we're going to do 0 times 0.061 plus 1 times 0.154 dot, 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 plus blah, 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 right? Plus the last one, which was what, 9 times 0.001. Great. That takes a whole lot of time. You don't have that kind of time on the AP exam. So what will save you time is if you enter it into your calculator. So you're going to do classic. You'll do stat or edit. You need to enter your data into L1 and L2. Here we go. So I entered my data into L1 and L2. Okay. I then go ahead, I'm going to just do the stat, go over to calc, right, one variable statistics, and we'll need to tell it that the list 1 should be L1, make sure L1 is in your list, and the L2 should be your frequency. And then go ahead and calculate. This will spit out your X bar, which is your average, or your expected value is X bar, which is 2.851 in this case. So our X bar, or our expected value, is that. And it'll spit out a bunch of other things too. But that should be your expected value. So go ahead and calculate it by hand. Also calculate it by using your calculator and make sure that you get that expected value. For those who have the older calculators, reminder, right, you're going to do the one variable statistics. So stat, go over to calc, one variable stats. And you're going to need to write L1, comma L2. It needs to know that the counts are in L1 and the probabilities are in L2. Great. Continuing with that, so go ahead and flip your sheet over. Make sure that after you've calculated that and make sure you got 2.851. We can also determine, if we can determine the mean of something, we can determine the standard deviation and the variance of that. Remember, what's the definition of standard deviation? Hopefully you're saying it out loud in your head right now. We know that that is the average distance to the mean, right? Our standard deviation is the average distance to the mean. Great. We also know that the relationship with variance, hopefully you're also saying this in your head right now, the variance is the standard deviation squared. Right? We took the standard deviation and we squared it. So it's always going to be, both are always going to be positive, but that will be the standard deviation squared. So, to find the standard deviation from our probability distributions, let's go ahead and use the second example since the data is already in our calculator. So that will say on average how much above and below the mean would you fall. Again, the same thing kind of applies here to find the standard deviation. And standard deviation we can know as, and then we're going to actually define this using the variance, and then we'll take the square root. So the variance of these probability distributions, right, or the standard deviation squared of our data set, right, our data set is denoted as x, so the variance of their standard deviation squared, right, or of x, right, is if we did all of our data points and subtracted the mean, we squared them and then multiplied it by our probability. Plus the next data point minus the mean, square it, multiply it by the probability. Dot, 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 dot. So let's go ahead and do that for the NHL data. So let's find the variance of our NHL data. What you would need to do is to take each data point. So the first data point we have is 0 goals. We subtract it by our mean, which was 2.851. Square it, and then multiply it by the probability associated with 0 goals, which is 0.061. Plus the next data point. If you score 1 goal, subtract the mean, square it, multiply the probability of getting 1 goal, plus da 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 da. right? That's going to take a long time to calculate and to compute. Thank goodness we have our calculator, right? So our calculator, again, also in one variable statistics, we're going to be looking right here at the standard deviation. So our standard deviation in this case is 1.6324. So that's our standard deviation. Our standard deviation is 1.6324. So to calculate our variance, if it asks that, we're going to take that number and we're going to square it. So if I took that number, 1.6324, and I square it, we'll have a variance of 2.664. So now you know how to go ahead and calculate standard deviation, variance, and expected value. One other thing I want to add here, when we found that expected value for the NHL goals, right, we got that it was 2.851. What that means is that the expected number of goals after many, many games for an NHL team is 2.851 goals per game. So after a long period of time, or after, actually in this case, after many games, right? After many, many games, the expected number of goals is 2.851, right? That's how many goals they'll expect. Obviously, they're either scoring 0, 1, 2, 3, 4 goals. That's why it's called discrete probabilities. But in this case, we're saying that on average, right? And that's the expected value. Expected value doesn't have to be a whole number, like the number of goals has to be a whole number, 0, 1, 2, 3, 4. Expected value can just be like over a long period of time, how many do we expect? 2.851. Kind of like we found out with the kids data, the children data. The expected number of kids was 1.96. Well, you can't have 1.96 kids, but the expected, the average number of kids would be that. Well, actually, you're only having 0, 1, 2, 3, 4, or so forth number of kids. So the expected value is not necessarily a whole number. All right, go ahead and do your classwork and then turn that in. Once you're done with that, you can do your homework by watching the next video. Thanks.